So guys, welcome again and thank you so much, Shinu, for the introduction. And this is a great pleasure to have you over here on a weekday. And I know it's not very easy for any one of us to really carve out the time to be here. So hopefully this 30-minute or whatever time we spend today should be worthwhile for everyone. And this session is actually more meant for answering your Q&A. So I have kept on purpose a very, very low number of slides. So I don't want to make it a one-directional road or just have a lecture and then everybody goes to their normal routine. I would really encourage you to sort of type your questions on the chat window. Or if you're comfortable unmuting yourself and asking me the question and coming live, you're more than welcome to do that, right? So with that, we will move forward, right? And, data science as a field and data scientist, everybody is aware of that, right? I mean, I don't need to tell what this is and so on and so forth, but I'll just briefly refresh the concepts and, what exactly I understand from the word data scientist or the field data science, right? And then I would like to draw your attention in terms of what exactly a data scientist do in a typical day-to-day environment in a typical job profile. And then also I would like to, towards the end, talk about some of the myths that people may have for a data scientist, right? And hopefully that should give you, some data points to think about and, some other thoughts that may come to your mind. And I'll be very happy to take up those thoughts and ideas and suggestions later on, right? So this is a quick pictorial view of what exactly is data science. For the folks who have very little knowledge about what data science is, I'll give you guys a minute to look into this slide, and then I'll just tell you my particular view of how I define the field, right? And this is broadly something that people would agree on, but there might be some nuances here and there. So I'll just give you a minute to take a look at the slide, and then I'll give you my interpretation of what is data science. All right, so let's hear from you on the chat window first. So what do you think are the key takeaways from you? How would you define that? What is this picture telling you? It's a very simple diagram, right? There are no, axes over here, just a simple bunch of circles and some text in it. What does it mean to you in your own word? Anyone? Feel free to ask questions. Let's make it interactive as well, yeah?
RP, sorry to interrupt. It's a training session. I think all are muted.
Not muted. I'm seeing the chat window. Can they type on the chat window?
You can see the chat window. They can communicate through chat.
Yes. So I'm not seeing any chat coming in. So guys, feel free to chat your comments, right? Otherwise, I'll assume that you're good. So I will tell you what exactly is my interpretation, right? So first of all, let's focus on the portion over here, right? And I'll just get my marker up and running. Right. So first of all, let's focus our attention on the title itself, right? So what does the title say? So data science is the art and science, right? The keywords over here are art and science. For doing what? For drawing the insights from the data, right? So as we all know that we are basically having tons of data coming in from a variety of different data sources, and some of you may also be aware that the data is following what we call as the Moore's law. And this is named after the founder of Intel, Gordon Moore, and he actually long time back in 1960s made a prediction that the amount of chips which are there on let's say 1 millimeter by 1 millimeter area will double every 18 to 24 months, right? So the parallel of the Moore's law is that the amount of data that we have is doubling every passing year, or every other it's going to be double, right? So whatever data we have right now, if you wait for another 2 years, 2022, the amount of data that we'll be having will be just about double of what we have, right? So that basically gives the credence to the growing and not just growing at a very, very rapid pace, and something that is basically becoming omnipresent everywhere, which is the data science, and how do we really take this data and draw the insights, because if you have just the data, it doesn't mean anything, right? I mean, everybody has the data. You name any company, whether it's a small scale, medium scale, or large scale company, they all have the data. But very few people have the insights, right? And that's where the data scientists really come in to go and look into this data and draw the insights. And when I say the insights, what it really means is basically the business application, right? Your insight could be very generic, but what really is important for business, whether it's in e-commerce, retail, medical, any other field that you can imagine, everybody is investing in the data science for getting a business value, right? And this business value can come in from variety of different avenues, right? And we'll talk about that. So on top of that, on top of this sort of like, the overall chart that you're looking at, the big circle is artificial intelligence. And artificial intelligence is nothing but the capability of giving the same level of intelligence to a machine as we human do, right? And if you look at the word and where we are right now and the evolution cycle that you're on, our brain has been trained for millions of years. So how do you take that amount of learning that we have done over millions of years via our forefathers and their forefathers and so on and so forth, and accelerate that learning into a machine where they can do things that a normal human person can do, right? For example, when you see somebody, you recognize immediately, right? That this is my uncle, or this is my aunt, or this is my neighbor, or this is my friend, and blah, 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 right? For a machine, this is a very, very hard thing for a machine to learn, right? Because they are not necessarily having that awareness. So how do you really build that capability and that intelligence in the machine is what basically the broad umbrella AI is, right? Now, AI is something that may use ML, that may use what we call as deep learning that I will talk about, or maybe just pure coding, like a computer engineer does, right? So it may or may not have any ML or deep learning part, and that's why you can see there is a certain area of AI which is different from machine learning and deep learning, right? Now, moving on, machine learning. So we just talked about the AI. So machine learning is basically a subpart of the artificial intelligence, and that is the branch where you actually expose the machine to the historical data, to tons of examples that you have collected over a period of time, and you give the machine, when I say machine, I mean just imagine that you're looking at a server or system or cloud, anywhere your algorithm is running, right? And that algorithm is actually looking into your historical data that you're providing, and it is able to build the linkages, build the pattern, and so on and so forth. And when the time comes, then that machine is making the prediction for you, right? Let me give an example. So let's say you are working in a banking company or in a fintech company, right? You would like for you to be able to tell when a brand new customer comes in or potential customer comes in, whether this customer is gonna go back and after I give them a loan, whether they will repay my loan or they will default on the loan, right? Because that's where your business is gonna sort of like, either make it or will not, right? Depending on how the losses are coming out for the business. So you would like to have a very reasonable amount of certainty whether this person is going to default on the loan or pay back on the loan, right? Now, you don't know about this person, right? But what you do know is that people who came in prior would have shared certain traits, certain characteristics like, demographics, the income, the geography they are coming in, the credit score they have, and based on that, you have already built a pattern, already built a model, right? And that model is able to make a prediction. So once you have this person coming in, you feed the profile of this person along with the financial and other data, and then you have a prediction that comes out. So that is basically what a machine learning algorithm does, right? And there are many, many different flavors of a machine learning algorithm. Some could be very simple, like a logistic regression or a decision tree. Other could be more complicated, like an XGBoost or gradient boosting trees, or any sort of ensemble model that we have, right? So that's the broader umbrella of machine learning, right? It could be a variety of different algorithms, but mostly looking into the historical data, trying to learn the relationship between what is it that you are trying to modulate and what the underlying drivers are, and then learning that behavior to make the future predictions for you. Now, within machine learning, we have a field called deep learning. So what is unique about the deep learning is that it is focused mostly on what we call as a neural network, right? And neural network is nothing but like a human brain really works, right? Which is on neurons, and certain action happens, but why those actions happen, what was the exact process, and so on and so forth, that is not very clear. But the decision was right? So that's what basically deep learning algorithm does, and there are tons of examples and applications around us, right? When you talk about the computer vision, right, or when you talk about the disease identification from a medical image, right, or when you talk about the automation like a robotic, right, all of those are being fed by deep learning algorithms, right? And there are tons of examples like convolutional neural network, LSTM, simpler one like the MLP, right? And RNN and so on and so forth. So I mean the list really goes on, right? So that's where the deep learning really comes in, where I mean they're trying to solve the problems for which a typical machine learning problem or I mean machine learning algorithm may struggle, right? Because of the complexity of the data, because of the complexity of the pattern and so on and so forth. That's where the deep learning algorithms really step in, right? Now going back to where we started, what is data science then? So data science is basically an intersection of any of these fields. So you could be doing deep learning, you could be doing machine learning, you could be doing coding for doing the AI work and all of that, and you could be just doing a simple Excel or the data visualization and stuff like that. So that's where it's a horizontal which cuts across all the different circles that we've talked about that, and that's what basically analytics and data science is. And we'll talk about more when we come to the myth section. But I'll pause over here and see if anyone has any thoughts, comments on this slide before I move on. So if you do have something, feel free to type your comments on the chat window. Otherwise, you can hold on to your comments and we will address those things towards the end of the discussion.
There is one question from Sharon.
What is the question?
Subset of DL, subset of ML, subset of AI and analytics and data science goes through all of these. A data scientist would have a business, technical and analytical and statistical knowledge.
Correct.
I think she typed half of the question. Let me unmute her and let her ask the question.
Okay. That's fine.
Sharon, you can ask the question.
Not a question. Said that.
That was more like a comment, I think. Yeah.
You told to comment on the chat.
Okay. Okay. Perfect. Good. So then we will move on, people, and feel free to stop me at any point of time if you have anything, right? So this is a busy slide. So I'm going to give you a minute to take a look at it. But this is if you were to ask me that how would you define a data scientist, right? What does it mean to you? And like I said earlier, even now, people who are doing Excel, they will write data scientist in front of their name. There's nothing wrong with, writing it. The only thing is that it sort of like, dilutes the whole notion of a data scientist, right? So what does it, a true data scientist mean to, me and to the wider audience is what I have listed out over here. Take it with a pinch of salt. So it's not like something that is cast in the stone or, that is the only way of defining a data scientist, but this is a directional thing that should give you an idea of, what I am looking at if I want to be a successful data scientist down the road, right? All right. So the first and the foremost is that you should enjoy coding, right? If you're somebody who doesn't like coding at all, you rather not touch anything to do with Python, Spark, Scala, R, and so on and so forth, probably it's not a good thing, right? So generally speaking, successful data scientists would have done 500 plus hours of coding, right, in terms of the assignments, the classwork, on the job, whatever, right? And that's what I'm saying. So becoming a data scientist is not sort of of like electricity switch that you go for certain course or certain certification, you immediately come out as a full-fledged data scientist. Obviously, you've taken a huge step forward in that direction. That's a journey. It's a consistency. It's a persistence. It's the rigor that you put in. And when you have 400 to 500 hours of good coding experience, then you are in a territory where you can go and challenge anyone, and you can be quite effective in terms of the work that you're doing, right? The second area is that you should be good at machine learning. So generally speaking, you should have done 10 to 15 statistical models based on the real world data, right? When I say the real world data, it doesn't have to be something that you have to go and ask your stakeholders and so on. So forth. There's tons of real world data on public forum, and you can leverage any of that, and you can document those things in your resume, and that will qualify as your real world data, right? So a real world problem means the data does not need to be something that is not available on a public forum, but the data is available on a public forum. However, it is solving a problem which is real rather than, a textbook example and so on and so forth, right? Third area is that you need to be having, good amount of statistical knowledge as well, right? So when I say statistical knowledge, you should know what is a t-test, for example. You should know what is a chi-square test. You should know what is a p-value, right? What is the significance of type 1 and type 2 error, what exactly it does, and so on and so forth, right? Some awareness about the big data technology, the entire architecture in terms of the cloud, how do you communicate with the technology stack will be definitely helpful in terms of just you being able to navigate that. And when we come to the explaining of what a data scientist do on a daily basis, you'll see that this point is very, very important as well, right? Knowledge about the deep learning algorithms, MLP, LSTM, CNN, RNN, and whatnot will be very, very important. But not every data scientist is doing deep learning. So let me be very, very clear that it's not 100% a requirement that every data scientist must be building a deep learning model, but most of the people will tend to be going in the direction over a period of time, right? These last four are my favorite, and they are the most ignored one, right? Because when we talk about the data scientists, people get this whole idea about the coding, the mathematics, the statistics, the probability, like every sort of, quantity related and quantitative areas that you can think about, but we forget how important it is to have the sort of like the necessary soft skills, right? Or the attitude or the background in terms of the education and so on and so forth, right? So problem solving, you must love to do the problem solving. And when I say problem solving, that means, a business comes to you, a stakeholder comes to you, your team member comes to you, and they tell you a very, very vaguely defined problem statement. Now, this is where you have to step in, and you're not thinking as a data scientist just yet. You're thinking more as a consultant in terms of, what is this problem? What is the tangible, intangible benefit that one can derive? How do I take this problem and break it down to the bite-sized pieces? How do we really define that? How do I really tell my stakeholders that I've defined the problem correctly, get their buy-in, get the entire sort of like, the process working on, and then take it forward in the modeling. There have been a lot of cases where people will build a model, but nobody buys that, right? So that's where your problem-solving skills, your, stakeholders management skills will be very, very important. And then, once you've done a fantastic job in terms of building a model, getting all the stakeholder buy-ins and so on and so forth, ultimately you have to present, you have to tell a story. And that's where your storytelling and the presentation skills will be super important as well. And then I think nothing beats the sort of like the work experience in the education one has in the related field. Now it's a chicken and egg. So unless you have the work experience, you really cannot become a data scientist, and vice versa, right? But there are cases where people will start small. You don't have to necessarily go and solve the most complex problem that exists for a data scientist. So you can start small. You can slowly build your track record, and over a period of time, you will get to that stage, right? So there is an article, beautiful article written by one of the bloggers, which talks about if one wants to learn everything that is there in the data science field, it will take 45 years and 3 PhDs, right? Now, nobody has that sort of time in this world, right? So you never ever get to the stage in your life where you say, okay, I've learned everything that is out there for me to learn, or I have known every statistical technique that is out there to be known. So that day is not going to come, realistically speaking. So, but doesn't mean that people who are working in the data science industry, they're not effective. They're effective because what they're doing, they are very good at, right? And vice versa. So, I mean, you can start small, you can start in one area, and then over a period of time, you can slowly go into the mode where you not only know just one area, but you are actually very, very comfortable in doing variety of different tasks in there, right? So that's what basically, in my opinion, a data scientist really boils down to. Any questions, thoughts, any general addition on the slide from anyone? And you can respond to everyone. So when you're typing your comment, so just from the drop down, if you select all attendees, the comment should come to all of us. So that way we can all see it. In case if you would like to share, if you agree, disagree, or you have a general comment, we'll be happy to hear you out. Yeah. All right. So we'll wait for your comments. And then this is little bit dated information. So this is as of I think July 2015. This is the data compiled by one of the very, very well-known publication, Wall Street Journal. And I think they have also taken some of the information from another equally good publication called O'Reilly, right? And they basically interviewed around 600 data scientists across the world. And they asked them, what is it that you do on a regular basis, right? And how much time you're actually allocating in what, different types of activities in different areas and so on and so forth, right? So broadly speaking, these are broken into 6 categories. So one is your EDA, which is the exploratory data analysis. The second one is more in terms of the data prep. Then your machine learning statistics, your visualization, your presentation, and your ETL, extraction, transformation, and loading, right? So I'll give you guys a minute and see what you make out of this. All right, so comment coming in. Guru Prasad says, if you do not have computer background, how to proceed? So Guru Prasad, I will answer that question. That is not required, right? I will come to that part when we go to the next slide, right? So any takeaway from you on this slide? Any broad insights? What do you guys think? Anyone? Okay, so here are some of the things that I have noticed personally, and I'm just being aware of the time as well, so that we have time for Q&A as well. So the word as we know, and the word that we live in, defines the data scientist as somebody who does only machine learning and statistics and so on and so forth, right? And you can see that is not entirely the truth, right? Besides doing the machine learning and statistics, you have to do a variety of different things. And a lot of time that you spend in a day goes in that. So for example, data cleaning, right? 31% responder says that they are spending up to 3 hours in doing data cleaning, right? In their typical day, right? 42% say that I'm spending less than 1 hour and so on and so forth. So you can read the chart. The bottom line is that a lot of things that you will consider as given, that when I'm starting to work as a data scientist, all I'm supposed to be doing is building this nice looking model with, fancy metrics and all of that. That is a partial truth. Before you even get to that stage, you need to visualize your data, right? You need to do basic data exploratory analysis to find what is it that your data is telling you. And even before you can do any of these visual analytics and sort of like, summarizing the data, you first need to fetch your data, I mean, nobody's going to give you the data on a plate that, hey, there you go build a model on this data, right? No, you have to get your own data. So you need to be comfortable in terms of talking to the, all the tools and technologies and the stack that the company has and how to fetch this information. Once you get this information, then you go to the data cleaning, which is, there might be bogus values, there might be erroneous observation, there might be columns or variables that you don't need and so on and so forth, right? Once you've done it, then you come down to sort of like, doing your basics or, more like a descriptive and diagnostic analytics. Once you've done it, then you go down to your machine learning or building what we call as a deep learning ML model, right, which is the predictive part. And once you have done all of that, your job is not done. A lot of data scientists will think, hey, I built a model, my job is done, now I can happily walk back to home. Wrong. You have to go and present your analysis to your stakeholders and you have to convince them, right? Nobody has taken a pledge that the moment RP comes in with a ML model, we will all stand up and clap and say your model is approved. We will implement it from tomorrow. It's not going to happen. You have to build a convincing story along with the business justification, along with the potential impact, along with, what are the sort of like, benefits that all the stakeholders will derive from it. It's like a regular salesperson job. I mean, when you're doing something in your day-to-day activities, you're selling yourself. You're selling your idea. You're selling the sort of like takeaways that you have. So the same thing applies over there. So it's not the bottom line from this slide is that it's not a one-trick pony that one has to be as successful as a data scientist. If you want to be really going forward in your career, if you want to be successful for long term, you need to be having some elements of all of them, right? Now, somebody can throw a challenge back at me and say, hey, do you have to be equally good in all of them? The answer is no. Maybe you're great at machine learning and statistics, but you need to be at least good in terms of presenting, right? Maybe you are great at presentation, but then you have the awareness in terms of what is an ML model and so on and so forth, and you have a bunch of data scientists who are working for you, but then you can digest what they are doing, and then you can take that story and, share with the stakeholders, right? So there are many, many ways of sort of like looking at this picture and then seeing, how I can add the value as a data scientist. And there are all flavors of it, right? Depending on the journey that you're on, depending on seniority you're on in the organization, you might be doing some or all of these portions on your own, or you may have a team that is doing it for you, right? Or you may have interns who are doing it for you. So, like, I mean, all shapes and shades exist, all colors and shades exist, but it will be some combination of these things, right? All right, so in interest of time, I will now talk about some of the myths. And I think, Guru Prasad, you asked a question, right? That do I need to have a computer background? The answer is no. So here are some of the myths. And this is just my view. You may do a quick Google, you may find some of the other myths. A lot of people say that I need to be a PhD, or when I look up for a job, they will ask for a PhD, right? If I look at the people who are working in the data science industry, I'll say probably not more than, I mean, this is very bullish figure I'm going to tell you, not more than 20% people have a PhD. At least in the India market, who are working as a data scientist, right? Now, if you look into the, for example, more advanced, markets like, let's say, San Francisco, right? And very, very higher end jobs, then that balance may be a little bit different. Then that maybe that more people have the PhD and so on and so forth, right? But not for most of us, that is not a requirement. Now, if you have a PhD, definitely it's a plus, but it doesn't mean that everybody has to go and rush for getting a PhD in order to become a data scientist. You can be a great data scientist without it. Number two, people who may have done coding earlier in their roles or in the job duties, it's a plus. But people who have no coding experience as well, learning to code is very, very simple. And we're not talking about learning to code in C++ and other cryptic languages. Python is very simple language to learn. In fact, nowadays they are teaching Python to the grade 6 students, So if a grade 6 and grade 7 students can learn Python, I'm sure people who have done, some bit of experience in the corporate world can pick it up as well. So all you need to have is the desire to learn, the patience to learn, and it's not very complex, right? Anybody can pick it up and learn, right? You can learn on your own also. But I think it's always helpful if you have some assistance and some support group to really take you in that journey, right? Third, just because you get a certificate or a diploma, it will definitely make you, go forward and give you sort of like, the momentum to become a data scientist, but doesn't make you a data scientist right away, right? So I hope that differentiation is clear. So you've taken a huge step forward, but becoming a full-fledged data scientist will be slightly more longer-term process. And besides the education, you have to be showing some work that you are doing, right? And that could be part of your education also. That could be part of the curriculum also that you're doing, right? But the case in point is that you have to really show the application of the learning rather than just the learning itself, right? And I keep on using this analogy to my different classes that if you have to hire a carpenter, you will hire a carpenter who's able to bring the work that they have done, right? Not a carpenter who has gone to the best carpentry school or a carpenter who knows the best tool out there, but somebody who has really done something with that and have example to show you that this is how my work looks like. So you have to be really sort of like, aiming for creating those examples, creating those anecdotes that people can leverage, right? Um, Fourth point is that if you see LinkedIn, suddenly the people, who were doing something else, now everybody is adding a data scientist in their title. So not every data scientist out there will be building a statistical model, right? So do not assume that everybody out there is doing an ML or deep learning or something of that nature just because they have added data scientist in their title, right? It doesn't work out that way. There are a lot of companies which are quite liberal with this, right? A lot of companies who allow the employees to write whatever they want to write in LinkedIn because they say this is not official. It's like any social media platform as good as Twitter or Facebook. I don't sort of like monitor what you see out there. So you can write whatever you want to write, right? So it doesn't mean that everybody who writes this title is great at doing ML and deep learning. So you have to take it with a pinch of salt, right? The last point is, let's say you've already started your journey forward and you have become much more comfortable and so on and so forth. A general bias that we have as data science community is that unless I'm building a very complex model that nobody can understand, probably I'm not a very effective data scientist, right? In fact, the truth cannot be, further away from what we just talked about. The companies are not hiring you to build a very complex model that nobody can understand. The companies are hiring you to create the business impact. And if that business impact comes in from a simple linear regression model, if that business impact comes in from, a simple visualization that you have done, and from there people are able to generate the insights and they walk away with some actionable, you are quite effective, right? So those are the myths in terms of, what people may think about as a data science and what exactly it takes for you to be successful. I know I'm slightly over the time right now, 6 minutes over, but I will pause over here and open up for any Q&A, any comment, anything that you have, and we'll be happy to unmute you also. I hope at least some of your questions are answered during the discussion, right? This is the end of the presentation from my side, people. We have 24 participants in the audience, and everybody should have an equal opportunity to ask me a question. Anything that comes to your mind, anything that is not addressed, we'll be happy to take it up. And Shinu can also jump in as and when required, right? So Shrikant says, should we be good in statistics since we have done it in 11 and 12th standard? Shrikant, no. Like I said earlier, a lot of people, and I've been doing the mentoring and coaching and training for the data scientists for close to 6-7 years now. So I've seen people who are coming in from a very non-quantitative fields as well. And initially, yes, you have to put in some time and effort in understanding some of the fundamentals. but it is not mandatory that you come in with all these knowledge ahead of time. But yes, you may be required to do a little bit of the prerequisite and make sure that you're comfortable, because these things are indeed important, and but not very hard concepts to pick, right? And the other thing that you have to keep in mind is the sort of like math and statistics that you would have done in your intermediates or your earlier classes, where you have to memorize the formula, where you have to memorize, like the whole equation and stuff like that. It does not apply the same way in the data science field. Nobody's asking you to memorize the formula. You have to be aware of the application of that. You have to be aware of that when I'm running this test. If I'm getting a certain result, what does it mean? If I'm getting the other result, what does it mean? Right? So it's more about the application than a pure memorization of the formula and the derivations and so on and so forth. Right? Other questions? Thank you, Srikanth, for that question. I think a lot of people would have the same thought in their mind as well. So I hope when one of you asks, others also get a good clarity about the sort of like the same area that they're wondering about. All right, let's hear from few more of you. Okay, so Guru Prasad says how a non-data analysis employee will be positioned in data-driven organization in terms of experience carry over. Okay, so thank you, Guru Prasad, that question. So it depends on what you have been doing in your role earlier on, right? If you have been working for any company in any role, you are picking up a lot of those skills which are also very, very important and pertinent if you are a data scientist, right? So for example, how do you work in a diverse team, right? Or how do you ensure that you communicate effectively, right? Or how do you ensure that you collaborate with all the different people, right? So that doesn't really mean that you have to be in a data science field in order to pick up those skills. So those will be directly transferable in terms of the work that you're going to do as a data scientist. However, the work area for a data scientist might be different from what you're doing as of now. There are a lot of cases where people have been able to leverage their past experience. So let's say somebody is working in software testing, right? So they're able to leverage their past experience and then augment that experience with the data science skills, right? There have been cases where I've seen people coming in from a very, very tangential background, right? Nothing to do with the software, nothing to do with the quantitative analysis, and even they have been successful in terms of building a career, but there's no guarantee. It's automatically a function of how much interest you have, how much efforts you're putting, because if I say how many of you are interested, I'm sure all of you will raise the hand, or at least 99% of you will raise the hand that I'm interested, right? But how many of you will really put the efforts? That's where you see that separation is going to happen, right? So it's a function of your efforts as well, but no background is a disadvantage. Your background may definitely be advantage or neutral at the very worst, but no background is a disadvantage, because data science application is agnostic to the domain. You can think about any area that you actually look into, whether you're ordering grocery, you're buying or selling the car, you're going for your medical test, anything that you name, I will tell you at least two applications of data science, right? And it is fast coming to the stage where people who do not know what the data science does and how exactly we interpret things and so on and so forth, they will become sort of like an obsolete job families moving down the road, right? That is what my firm belief is. Okay, good. Other questions, comments?
What RP said.
Yeah, Gershini.
Just RP said, we have been training working professionals from with people with 3 years of experience up to 20 plus years of experience, and in our understanding, nobody comes with all the prerequisites. Prerequisites as per RP could be your coding skills, your statistical understanding, your domain understanding, and analytical skills and storytelling. Nobody comes to our programs or we have seen data scientists with all these skills as prerequisites. So there could be some of these as one of their prerequisites which could be the right one for you. The rest of it could be learned. If you take up say a comprehensive programs like what we offer, then maybe that is a good way that you can get exposed to all these diverse fields in one go and then practice as much as possible, apply as much as possible and become a good data scientist. So we would request you to look at some of our programs and maybe walk into our campus and we could discuss more. And we also will meet you in person.
And there is a question from one participant. What are the programs offered from REVA University for the working professionals?
Okay, so this is we run programs which are data science. We have two long-term programs. One is a PG Diploma MBA program in Business Analytics, and another one is PG Diploma MTech program in Artificial Intelligence. Artificial intelligence prerequisites are very much more rigorous than a business analytics program. So we could share that details. We also run MTech program in cybersecurity, but that's not for that is a very different target group. We also run short-term analytics programs customizable for different groups for organizations. So you can check at our website race.reva.edu.in to know more or visit us in person. We would be happy to help you.
And one more question for RP. What level of expertise we require in Python coding to become a good data scientist?
Okay, sure. Thank you, Pawan, for the question, or the participant who asked the question. So, I mean, if I show you the actual models that we built for, like, the real world application, you'll see the code itself is not very complex, right? So I will break your question in two parts. One is more in terms of the ETL, which is the extraction, transformation, and loading, and the other one is more in terms of the model building and the ML. So the ML and the deep learning part of the Python coding is not really very complex, and anybody can pick it up, right? For the ETL part, there are a lot of companies which may or may not be using Python. So I know for sure even some of the big companies, are still using SQL for pulling the data from the, either the cloud or the servers or wherever they have hosted the data, right? So Python is very important from the ML deep learning point of view, but probably not so much important in terms of the getting the data to, the place where you can actually pick it up and then take it forward for the model building, right? And whatever is required in terms of the Python for building a great model, that skill can be picked up very quickly. And if you go look up some of the like participants on the Kaggle, right? Kaggle, for those who don't know, is a very well-known platform for hosting data-related challenges, and there are like tons of prize money and so on and so forth. Some people also find a job if you're successful in terms of meeting the criteria for that. You'll see a lot of people are actually coming in from the non-coding background, and they are self-taught data scientists, or they have been just passionate about the area, and over a period of time they have picked up the skill, right? So the short answer is it will be important, but nothing that, you have to be like, on a scale of 1 to 10, you have to be 9 to begin with, right? So you can begin with or maybe 4, right? But over a period of time, as you keep on doing things, obviously you will get better and better, and you'll get more comfortable in doing things that you were not able to do earlier, right? All right, good. So hopefully that answers your question. Yeah.
That is the last question, RP. I think we will end the session here.
Yeah.
Okay. Thank you for that.
Thank you, everyone. Thanks, RP.
Thank you so much, guys. Thanks again for coming in, and I appreciate your time. Thank you so much. Bye.